everybody, this is Amy here. Just wanted to talk to you today a little bit about the respiratory system and specifically about the different pressure changes that are involved in actually helping us to breathe. One of the major things that we need to think about in terms of respiration has to do with the pressure gradients that are involved. If you remember, in the last couple of chapters earlier on in the semester, we talked about concentration gradients and how molecules always move from an area of high concentration to an area of low concentration, and that's a passive process, right? That would be transport that allows molecules to move from a high area of concentration to low, no energy input required. The same basic concept applies when we're talking about respiration, except instead of talking about concentration gradients, we are talking about pressure gradients. And gases, like the air that we're breathing in, gases are always going to move from an area of high pressure to an area of low pressure. So if you think about this as an example, if you have a whole lot of people that are clumped together in a tight space, there's going to be some high pressure there. They're not going to be comfortable. But as soon as you open up that space into a larger volume or a larger area, all those people are going to immediately start to spread out evenly to really get as far away as they can from each other, because that's going to be more comfortable. And that's going to be just a natural process that all people are going to take. So that's just an example of what we're talking about here. Pressure gradients are always going to direct the direction that air is going to move. So we have to think about one thing. We have what we call atmospheric pressure, and that simply means the pressure of the air surrounding our body, so in the outside environment. And interestingly enough, in regards to breathing, that atmospheric pressure doesn't actually change. That's going to remain constant. But what does change is the pressure inside the thoracic cavity. So we, with our bodies, are actually going to create the pressure gradient necessary to both pull air in passively and also create the pressure gradient that's going to push the air out. So we're not doing anything to the air itself except creating a scenario of a pressure gradient that's going to naturally cause the air to move in both directions. So let's talk about this in basic terms first. If we are talking about thoracic cavity, and I'm just going to draw it here for now, and here is our atmospheric pressure on the outside. Atmospheric pressure, remember we said, is going to stay the same. If we do something in our thoracic cavity that drops the pressure below atmospheric pressure, that means that the pressure inside is lower, the pressure on the outside is higher, in what direction is that air going to move? It always goes from high to low, so air is going to go into this cavity, into our thoracic cavity, which is where our lungs are. On the other hand, if we do something in the thoracic cavity that's going to do the opposite, it's going to make the pressure inside the thoracic cavity higher in comparison to what's going on in the atmosphere, then we know that air is going to passively move out. And if you look at this, this is what happens when you inhale and when you exhale. You are simply creating pressure changes that cause the air to move. So I'm going to erase all of this that I've drawn so far so we can start over. So we've talked about the gradient. Now we need to look at how we actually create these changes. And this figure is going to help us with that. We have two major sets of muscles that we're dealing with. We have the intercostal muscles. They're shown on both sides, but they would go all the way around the thoracic cavity. They're the little muscles between the ribs. And then we have the diaphragm. And these muscles contract to change the size or the volume of the thoracic cavity. When the volume changes, then the pressure inside that container is going to change. So if we look at this, if we have a particular size container, that's really our lungs in this example, and we shrink down or we decrease the volume, you can see how all of the molecules are a lot tighter together. So that means that if you decrease the volume of that container, what do you do to the pressure? You increase the pressure. Same thing. If we take this same container and we make it bigger, but we don't change the number of particles inside, you end up decreasing the pressure. So if we increase the volume, we decrease the pressure. So that is called an inverse relationship. increase pressure, decrease volume, decrease pressure, increase volume. That's how that's going to work. So getting back to these muscles, let's see how they are involved in the process. When intercostal muscles contract, what they do is that they pull the rib cage out and up. That's going to expand the volume of the rib cage. If you put your hand on your chest and you breathe in, you feel your sternum go up. If you put your hand on the sides of your ribs, you'll feel your rib cage expand outward. So what that's doing is it's making that thoracic cavity larger. You also, on the underside, have the diaphragm. The diaphragm in its relaxed state is like this. It's in a dome shape upwards. But as this diaphragm contracts, what happens is that it actually goes flat. So a contracted diaphragm goes down flat, and because it's attached to the lungs, it's going to increase the volume of the lungs, increase the volume of the cavity from the underside. So contraction of the intercostal muscles expands the rib cage outward. Contraction of the diaphragm expands the rib cage on the underside. So both of these contractions are going to increase the volume of the thoracic cavity. So when we inhale, you can see here in this diagram, let me find my pen, there we go. When we inhale, which is what you see here, the intercostal muscles contract, expanding outward, diaphragm pulls down, and you increase the volume. When you increase the volume, you said you decrease the pressure below atmosphere, right? And so our atmospheric pressure is now higher, and so air is going to move into this lower pressure cavity, which is in the lungs. Now, when we exhale, we're going to do the opposite. The diaphragm is going to relax, which pushes upward on the bottom side of the lungs. The intercostal muscles relax, and we have another set that actually pull inwards, and so the thoracic cavity compresses from the outside. So we are shrinking the volume of the cavity, which is going to increase the pressure of the cavity. And again, in comparison to atmospheric pressure is lower now than this high pressure scenario that we've created. So now air is going to passively move out towards the low pressure on the outside of the body. So this is how pressure creates respiration, or inhalation and exhalation.